Neil from Messick's here to take you on a very special trip with us today. We were invited out here to Chicago by these two gentlemen, Russ and Dan, two of the guys here from HydraForce. They're going to take us around the factory here today and show you some of the industrial Legos that are used and putting together a lot of the equipment that you buy. When you walk up and flip up the shield on the side of a machinery, take a look in the inside and find some really impressive looking hydraulic work. It's a good chance these guys had a hand in it. So we're going to go walk around here today, show you some things that might help you appreciate your machinery a little bit more.
Messick's, a helping hand with your land.
The two basic elements of putting the valve together is assembling all the pieces together, and then we hydraulically test everything. So we do a 100% hydraulic test that simulates the customer requirement at the end.
This is like a proportional pressure reducing valve. I kind of mentioned to you, like a typical valve that would take higher inlet pressure and then vary the output pressure to like a spool or to a clutch or something like that. Yeah, but it's, you know, a coil operated proportional valve that the ECU, you know, communicates with in order to control the hydraulics on the machine.
So mechanically you have what, pressure coming in?
Yep.
At the screen, pressure coming out at the ports.
That's actually, that's tank. The pressure coming out to the spool would be out the bottom.
And then in the top point of this is what, a solenoid.
Yep.
Now to my brain, the solenoid is on and off. So is that not the case here?
Right. In the case of this one, what we do is we actually can proportionally change the position of that, what you call the plunger, I guess, right? Versus an on-off, yeah, you're right. You send a current to it, it just snaps, right?
Right.
But this one actually, we controlled it proportionally, right? So, and in this case, with this type of product, you're kind of actually balancing a force and a position at kind of the same time. Okay. That's what you're doing there in order to regulate a pressure.
Cool. So is then, as you go through these stations then, you're basically putting together all the different portions of the valve. Do they all get tested over here then?
Yeah.
All pressure tested?
100%, yep.
You can't walk past this. So, so this is all parts.
Yep. Yeah.
We're a make-to-order company. Even though we're a high volume, we do some high volume and low volume, so we balance the make-to-order versus the make-to-stock.
I have like a customer like, you know, JLG or somebody come to us and say, I need to have a certain performance, you know, and we might not be able to do it with the standard product, so we tweak it.
Right.
That adds another part number to our mix, you know what I mean?
So how much would you say there would be a skepticism with our customers sometimes of the manufacturer tweaking things just a little bit so that the parts are hard to find or they can't fix them themselves or whatever, but your side would see the engineering of that, I suppose, right? Yeah. Of the reasoning why that stuff is done sometime is...
It has to be done in some cases to get better performance that they're looking for their customers. Now, they would, I believe this, they want standard components because it's less costly for them and they're easier to source, right? When they make a special product, now all of a sudden their volumes are the only thing that control the cost on that product, the availability of that product, versus, you know, if they pick a standard product and they can use it, then that standard product's available, you know, more available from us, right? And the costs are based on the millions rather than on the thousands.
Yeah. So from the horse's mouth here, right?
Yeah.
It says those things are done for a reason. It is a performance-driven choice.
Exactly. So we do a lot of custom manifolds, right? That's what we call these. Yeah. And like I said, you know, you design a hydraulic circuit and then you plug in the cartridge valves, right? So like this is kind of a weird looking shape, right? Yeah. Well, it's because it goes on an ag tractor and it's used on the suspension of an ag tractor. Okay. And it has to fit into that small tight area on an ag tractor. And so we have to make this kind of odd shape, right? You can see there's an O-ring groove on the back there, right? So it's mounting right onto the housing, right, of that piece of equipment. So, yeah. So we make some really weird. This one's in pretty high volume. It's got its own line, you know, for assembling it all together and everything that we put together. So, yeah. Sometimes customers want it a different color, like. You know, Boss, I think we've got a red one. It's a red anodized on the Boss one. So, green too. Yeah, green. Yeah, so like in this case, that customer wanted it black for whatever reason. Maybe it hides it a little bit in their machine. You know, sometimes their machine isn't black, but it's yellow on the outside, but inside they want it black. Yeah. So we can do that. Cool. what we can do with cartridge valves is we can take multiple functions and we can combine it into one cartridge. Okay. And so that's what we did here. So there's a whole bunch of different functions in that one cartridge, which makes it really easy then to replace if something's going wrong, you know?
Wow.
Yeah.
So then you guys are machining all these parts?
No, we buy a lot of these components, but we assemble all of that.
Okay.
Yeah.
So this is that part that we were seeing through honing, basically.
Yeah, exactly.
And then you're snapping on the O-rings, the Teflon
and
parts.
putting the spools inside and springs and all sorts of stuff in there. Yep.
Wow.
Yep. And then that's the actuator portion of the solenoid. Okay. But you don't have the coil on it.
Right,
yet.
right. So the coil would sit over the top of this.
The coil goes on top.
Yeah.
We do, you know, we're not just a high volume company. We do a lot of custom low volume work, and manifolds is one of them. So we have a couple lines that are dedicated to 10 pieces or less. Okay. Right? Because a changeover, as you can imagine, on a line can take a long time. So we dedicate those low volume to certain lines so that we can keep the higher volume lines running more, and we're not changing
That's amazing.
everything over.
10 pieces.
10 pieces or less. We do one.
Yeah.
Wow.
Well, especially prototypes, but then service parts. So, you know, our agreements with the OEMs are that, you know, we have to supply these parts, you know, for a long period of time because those machines go out in the field, right? Yeah. And they may change models, but those machines are still out there. So we still have to service those for a long period of time. Yeah.
So so those machines are out, and I've seen this it's not a huge failure rate part.
Yeah, right.
But you're still obligated to provide it.
Yeah.
So
well, they might rebuild it. You rebuild some stuff.
Oh yeah.
All the time. So you'll rebuild it. Yeah.
Yeah. Or pull a valve out, or put a new solenoid on the top.
Yeah.
So I still, even now, I get blown away by just the number of different types of valves that we make here.
Yeah.
And just the proliferation across, a valve type.
No, I mean, you turn around and look behind you.
And you see all the product.
Yeah, I don't like to look at that. That's a different animal. Those are all waiting to go to manifolds, by the way.
Yeah. Right.
So they get kitted here, and so that's stuff I like to see get turned very quickly.
Yeah.
But
we're probably waiting for one valve or something, or a part from one valve, or.
We complete the valve, we test the valve, we kit the valve. So, like a block like we were just looking at has, multiple dozen different valves that will go into that. Before they come over here to P3, we kit them for the manifold order and make sure they're all kitted together. And those valves come over here in the form of the kit. And then you got all these other, miscellaneous fittings and other things that go into the block. That all gets kitted, but in this area we also do more cleaning. Okay. The key to a manifold, as you can imagine, is making sure you put the right fitting and the right valve in the right spot, right? Yeah. And it's really easy to mess up, especially when you're changing over and you got low volume, high mix. That's like a really big deal. So we use templates that are kind of a pokey-yoke type of a system where you can only put certain things in certain spots.
So you can't do it wrong.
Can't do it wrong, right? Yeah. We have drawings, color-coded drawings for each step in the process. Okay. That is very concise about what they're supposed to do and how they inspect it. We have a lot of color-coded. These color-coded palettes there are used to match with the color coding on the drawings. Okay. All right. And then we also have certain lines that are particularly at the end, so the fittings, right? A lot of our customers want us to put the fittings in. And we took that over, not long ago, right?
No, it's been a while, yeah. But I think we've been increasing. That demand's been higher and higher. Yeah, we have templates that we use even for orienting the coils and stuff like that, because that's critical. Within, our OEM customers will give us degrees of tolerance, for how the fitting or the connector has to be. Right. And so we actually have a 3D printer, and we actually design our own templates and now make them on the 3D printer, for use in manufacturing. Cool. So, yeah.
In addition to, the precision that are required to assemble a manifold, obviously torque is a big deal. Right. So we have, torque tools, adjustable torque tools to make sure that all the valves and all the fittings, everything in that manifold is torqued to the correct setting. Okay, so we, obviously a line, to have all the adjustable torque tools is a requirement for each one of our lines.
So we, like the biggest fear for a lot of people going to electro hydraulics is that these coils will fail, right? That they're fragile, right? But we spent a lot of time developing these so that they don't break. So in our lab, you're going to see like ovens and freezers and a big chamber where we salt spray test these things. We try to get water. The thing that causes a coil to fail is water gets inside, and there's a copper winding in here, and that copper winding gets moisture in there, and then it just rusts or has a short circuit, and then it doesn't work anymore.
The thing that I always see, like when we tear this stuff apart and work on it, you look and say, oh, wire's scary, but usually what? A nut on the top, slide it off. Slide the next one on, pull it back on. So even when you do have to work on them, it's not.
Yeah, it's so easy, right?
Yeah. Flexible across lines. We try to dedicate people as much as possible to a line, but it's also important that they're flexible.
Right. So that was my question walking through there, because it looks like this is not the same every time.
No.
Right. So what's the typical training look like for somebody doing this?
Well, we have, it's TWI, training within industry, and it's a very specific process, very specific documentation, and that's why all this reference documentation is very critical where it comes to training. But we align a new person with a supervisor or a lead or a qualified TWI trainer. And there's a whole process with the TWI training that we don't release them to the floor until they pass the ability to train.
So they're going to be able to go through and recognize, based off of the drawing, the part number of every piece that needs to go into that block and where to drop it in.
That's part of the training. They'll learn that. They'll learn where to get that information and what it means. It's, as you can see, it's a pretty physical job.
Yeah.
Right. And so getting the right person. The people that work here and do well, they love working here. They love working on the line.
Yeah.
You just can't go out and find a lot of those people.
Right.
So we have 2 shifts here. So we have a first shift and a second shift, and we basically are working 20 hours a day.
Wow. Yeah, it does seem like you're not a robot at this. I mean, it's just, you're definitely using your brain as you go through and put all these parts together.
Yeah, it's hard to automate this.
Yeah.
Companies have proposed ways to automate this, but it's hard.
Yeah.
It's very difficult.
This is that sub-assembly, the RV adjuster. It's an adjuster, a sub-assembly that we use for our RV valves. And we created this automation because, of the tens of thousands of RV valves that we make, we had a lot of dedicated, I think probably a dozen dedicated people putting this sub-assembly together that now we do on the automation. Certain torque values that we have to hit, or certain testing that we need to make sure these all go through. But again, one person on first shift makes all all the sub-assemblies that we need for this particular sub-assembly versus the dozen that we needed before.
Yeah.
But this is a full check valve automation for 8 and 10 style check valves. You can imagine all these little springs, they get twisted up and they get tangled, and this is a particular piece of equipment that tumbles them and keeps them from tangling up. So this thing, as the machine's running, this thing's in the background kind of spinning these things around. But again, this was our last piece of automation that we got. In the UK, there's some RV valves that we're actually doing the complete manufacture, including the test. You know, there's a whole test function that's required for the RVD58. That's actually, we're able to start getting that going. Yeah. Replacing all the RV08. They're caught up with all their production as of this weekend.
Yeah, yeah.
You know, so we're looking at some automated testing. Anything that's high volume, it's just in our business with the high mix, low volume,
right.
It's really tough to automate.
Right.
So we're automating pretty much everything we can. Right. You know, it required the touch of these gals out here that put these valves together. To make sure the ball was seated correctly. That's all done now. You know, internally with the assembly machine, it's much more, the variation is much less, obviously. So, you know, when you look at this department, we have, I don't know, like 10 machine tools, and we have 3 or 4 people working here, right. You know. So the key is setup, but, you know, here's another cage grinding that we do. It's pretty amazing stuff when you think of the high speed and the precision that's required. And these guys are really, you know, the guys that work in this building they're the best. Yeah.
So what, the robot loads the lathe then from the other side, and then it's honing out there?
Well, it's an actual grind. Okay. So we're removing material. It actually probes first to make sure it's lined up correctly. It's fixturing on the outside of the part. So if somehow it's not in there correctly and you grind it, it's a scrap part.
Right.
You know, they're at the very beginning of producing the part, right, or the valve, right? But this is so critical, because if this is done well, then it goes to assembly, it goes together right, it gets tested, it passes, it works well, gets to the customer, works flawlessly for the life of the product. So that's how critical this is, and that's why we like to do it in-house, you know, and be able to control it ourselves.
Right.
That's a tough one. That's an ID-OD. Right. Yeah, because this is a spool. It goes inside a spool. So it's got. Okay. I mean, it's got a spool that goes inside the spool. Then this is around the cage. So this is balancing pressure over an orifice is what it does.
So what's all the grooving on here then?
So that communicates oil. Okay. In the part. So it just.
It's lubrication.
Yeah, exactly.
Yeah.
Plus, there's a movement requirement as well, right? Yeah. That if that was all one solid.
Yeah.
Piece, you know, you could create some other hydraulic issues.
That part's constantly moving because it's balancing, because like you can have different load pressures versus pump pressure, but you want to have the same speed, and so that's what that does. That just keeps that speed going constant.
This is in-feed grinding. We've automated all this. This was cool because, you know, again, we had one person man for each one of these machines. And you can see how the robot works. When we talk about in-feed, it's pretty much self-explanatory.
Yeah. So when you talk about like what you would insource versus outsource, then it's that tolerance.
Final fit and finish.
You're bringing in basically rough parts, and then getting them down to your tolerances here.
Yeah, the final fit and finish.
So you got a green machine nose. That's the turning.
Right.
And then you send them out to heat treat. Heat treat distorts it. So you got to leave material on at the machining stage for that distortion.
Right.
And then grinding, you finish grind to the finished tolerance. And that's what we're doing here. So one guy now can run these 3 machines per shift. And it's just a matter of setup. Yeah. And the other thing that we were doing with this brushing here, that was stuff that we were brushing over at P1 with 5 people, right? Now we're doing it at the machine. These are 2 new DMGs that we have. Again, this is for block manufacturing. These were a little bit more efficient. We can do different types of blocks on these machines. Multi-tool changer. So the way we set these up, we can, you don't see an operator here. We can set the machine up, we can walk away, and you have one guy that can run 3 or 4 machines. We set these up to run overnight, on their own until they run out of blocks to machine. We call these tombstones.
Yeah, this one right here.
So these blocks get set up in these tombstones. Okay. So these are multi-axis machines. They have tool changers. So we literally can have almost 0 extra setup for going from one part to another. It's all a matter of programming.
Okay.
So we can set up, and there's 8. I think there's 8 tombstones on each one of those. We can literally make 8 different pieces on the same setup.
So basically then you have that set up to hold the block, and then the arm just goes in and...
Now you need one more, with these machines you need one more setup, because on the face that it's mounted against,
right, you don't have access.
You got to turn that one around.
Yeah. Hope you guys appreciated that as much as what I did. It was a really cool look into the engineering and the production that happens in some of that hydraulic componentry that you'll find in your equipment. It's really cool to be able to appreciate the process that goes into these things, see the people behind it, and come to a little bit more of a respect maybe for the machinery that we're able to operate and enjoy today. So thank you to the guys from HydraForce for having us out here. They don't have anything to sell you directly, even though you're gonna find a lot of their componentry in the machines that are gonna be sold by a lot of the major manufacturers out there. They thought it was worth our time to be able to show this stuff off, and I really appreciated the time that they took to do that. So thank you.